Hello, I am Srikant Reddy. In this lecture, we are going to see solution of linear algebraic system of equations, in particular homogeneous equations. So consider the system of m linear equations in n unknowns. That is a11 x1 plus a12 x2 plus and so on plus a1n xn equals to 0. a21 x1 plus a22 x2 plus and so on plus a2n xn equals to 0. Proceeding like this, am1 x1 plus am2 x2 plus and so on plus amn xn equals to 0. This is a homogeneous system of equations. Now we want to find the solution of this homogeneous system of equations. Remember one thing, homogeneous system is always consistent because if I plug in x1 equals to x2 equals to x3 and so on xn equals to 0, it always satisfies the system. Therefore, homogeneous system is always consistent. Okay. Now, our intention is we are searching for non-trivial solution. x1, x2 and so on xn equals to 0 is said to be a trivial solution, which is always by default it will exist. But we are focusing on non-trivial solution. For that purpose, what we have to do? So here the coefficient matrix is A equals to A11, A12 and so on AN1, A1n. Similarly A21, A22 and so on A2n, AM1, AM2 and so on AMN. So this is the coefficient matrix. So augmented matrix is no use here because if you are appending here 0, 0, 0, that don't give any impact on the original matrix. Therefore, it is no use. Since x1, x2 and so on xn equals to 0 is always a solution of the above system, so it is always consistent. So we test its consistency only for non-trivial solutions. So that is our aim, because trivial solution anyhow is a solution. Therefore, we are searching for non-trivial solutions. Now, how to get the non-trivial solution? For that, we have to follow these two simple steps. What is the first step is find the rank of the coefficient matrix A. So first you have to find the rank of the coefficient matrix. Next, step 2. So we calculated the rank of the coefficient matrix and we got some value. So let that rank is R. I am taking the rank is R. So let the rank of A be R. Now, we'll check these three conditions. First one, if rank of the coefficient matrix is equals to the number of unknowns n, then the system has only a trivial solution. So you don't have any other solution except the trivial solution. This is true whenever rank of the coefficient matrix is equals to the number of unknowns. In that case, it will have only trivial solution. So there is no non-trivial solution. Suppose if rank of the coefficient matrix is less than n, then the system is consistent and it will have infinite number of solutions, and that is also in terms of n minus r arbitrary constants. So whenever rank of the coefficient matrix is less than the number of unknowns, then the system will have infinite number of solutions, and those solutions will be in terms of n minus r constants. And the third one, this is also one observation. If the number of equations is less than the number of unknowns, then the system has solution other than trivial solution. So it will have solution other than the trivial solution, and the number of solutions in this case is infinite. So this is also one observation. Now we will see a problem on this. So here the system, which is clearly homogeneous. Homogeneous means if you look at the right hand side, it is 0, 0, 0. So now we have to solve this system. Okay. So the given system of equations is x plus 2y plus 3z equals to 0, x plus 3x plus 4y plus 4z is 0, 7x plus 10y plus 12z equals to 0. So first we will express this in the matrix notation. So as Ax equals to 0 this side. So A is the coefficient matrix, x is the column vectors of unknowns. Okay, so from this, first I will write the coefficient matrix. So what is the coefficient matrix here? A 1 2 3 3 4 4 7 10 12. So this is the coefficient matrix. So first we will reduce this coefficient matrix to echelon form. To reduce this into echelon form, what I have to do, I have to make this entry 3, this entry 7 and this entry 10 as 0. So for that purpose, what we are doing is, first I am subtracting the second row from the first row by multiplying with 3. So that is what here it is, the row operation, R2 minus 3 times of R1. Similarly, to make this entry as 0, we are subtracting from 1 by multiplying with 7. So R3 minus 7 times of R1. So if you make these two row operations, you will get this is 0 and this is 0 clearly, that you can see it here, 0 and 0. So accordingly, this is 3 minus 3 is 0. So 4 minus 6 minus 2, 4 minus 9 minus 5. We are multiplying this first row with 7, 7 minus 7, 0, 10 minus 14 minus 4, 12 minus 21 is minus 9. Now I have to make this entry minus 4 as 0. So that is very easy. What I will do is, this is the third row, R3 minus of R3 minus of 2 times R2 gives the entry is 0. So now the coefficient matrix is in echelon form. So once it is in echelon form, what is rank? Rank stands for number of non-zero rows. How many non-zero rows? 3 non-zero rows. Therefore, this is the rank. So rank is 3. Similarly here, the number of unknowns is 3. So whenever rank is equals to the number of unknowns, then the system will have trivial solution only. There will be no other solution except the trivial solution. That is x, y and z. Both, all the three must be equals to 0, 0, 0. So this is the only solution which will satisfy this system. There is no other set of values of x, y, z which will satisfy this one. So that you can observe here. So rank is 3, which is equals to the number of unknowns. Therefore, the system is having only the trivial solution. Next, if you focus the next problem, solve the following equations. 4 equations are given in terms of 4 unknowns. So the given system is here x plus y minus 2z plus 3w equals to 0, x minus 2y plus z minus w is 0, 4x plus y minus 5z plus 8w is 0, 5x minus 7y plus 2z minus w equals to 0. So these are the 4 equations in 4 unknowns. Now the procedure is, first write the coefficient matrix. So this is the coefficient matrix, 1 1 minus 2 3 and 1 minus 2 1 minus 1, 4 1 minus 5 8, 5 minus 7 2 minus 1. Now I have to find the rank of this matrix by reducing it into echelon form. To reduce this into echelon form means I have to make it as a upper triangular matrix. I have to make it as a upper triangular matrix. That means you have to make these entries as 0. 1 4 5 make it as 0. Similarly 1 minus 7 make it as 0 and 2 also 0. So what is the procedure? I will subtract row 2 minus row 1, R2 minus R1, R3 minus 4 times of R1, R5 minus 5 times of R1. Okay, so if you do that operations, so R4 minus 5 times of R1. So here some mistake is there. Okay. So by doing that operation, we will get 1 0 0 0 like this. Now, if you make the remaining entries also, so now it is in the echelon form clearly. So what is the rank of this matrix? Means the number of non-zero rows. How many non-zero rows? 2 non-zero rows are there. And how many variables are there? Unknowns? 4 are there. So rank is less than the number of unknowns. So what it indicates? The system is having non-trivial solution and it is having infinite number of solutions. So it is having non-trivial solution, and that non-trivial solution is nothing but it is having infinite number of solutions in terms of how many arbitrary constants? N minus R. Here N stands for number of unknowns. 4 unknowns are there. R stands for rank. That means N minus R means 4 minus 2, 2 arbitrary constants. So this system will have non-trivial solution, that is infinite number of solutions in terms of 2 arbitrary constants. Now I have to select those 2 constants. So if you go by back substitution here, this is 3y minus 3z plus 4w equals to 0. 3y minus 3z plus 4w equals to 0. X plus y minus 2z plus 3w equals to 0. So here I have to choose 2 arbitrary constants, right? So I am choosing w equals to k1 and z is k2. So from that, what is y I will get? So y is 1 by 3 times of 3z minus 4w. So we selected w is k1. So 4 by 3 k1. Z is what? K2. So 3 k2 by 3 is k2. So this is y. Then I will plug in this y value, z value and w value in the first equation. From that I can calculate x. Now if I write that x, y, z, w, right, we will see like this, right? So what is x? X is this one, y is calculated this one, and z is k2 and w is k1. Now clearly the system is having non-trivial solution, and it is also having infinite number of solutions. So I can choose k1 and k2 any values so that I can get infinite number of solutions. So this is the procedure to calculate the solution for the system of algebraic equations in a particular case of homogeneous system. I hope you understood this session. Thank you.